Imagine handing an AI a script of just complete and utter gibberish, like the quantum blockchain leverages distributed photon matrices.
Right, just total word salad.
Exactly. Normally, if you feed garbage into a standard video generation tool, you get garbage out. Or, it just completely crashes.
Yeah, that's the standard input-output problem.
But imagine a system that reads that script, tries to make the video, stops, looks at its own work, and actually realizes the audio narration makes zero sense.
It catches its own mistake.
Great. And then, without you lifting a single finger, it isolates the failure, rewrites the audio script to actually be coherent, leaves the perfectly good visual frames intact, and delivers a flawless final cut.
And all before you've even finished your morning coffee.
Yes! Welcome to the deep dive.
It sounds like science fiction, honestly, but it is exactly where the technology is right now.
It really is. Today, we're opening up a massive stack of curriculum materials and research notes, all centered around a really comprehensive course titled AI Agents for Image and Video Generation.
It's a fantastic course.
It is. And our mission for you today is to pull back the curtain on how we are moving away from typing simple text prompts and just crossing our fingers.
Hoping for the best.
Right. We are looking at how to build multi-agent pipelines that generate, evaluate, and actually self-correct visual media at a massive scale.
What's fascinating here is the fundamental paradigm shift. Because, well, for a long time, we've been dealing with models that handle discrete tokens.
Like text and code.
Exactly, text and code. That stuff is very black and white.
No.
A word is a word. A line of code either compiles or it doesn't compile.
Sure.
But now we are pushing these autonomous systems into high-dimensional, continuous perceptual data.
Which means what, exactly? I mean, break that down for us.
It means rich, pixel-dense images. It means cinematic video with lighting changes that happen over time. It means synchronized audio.
So way more complex than just predicting the next word in a sentence.
A massive leap in complexity.
Yeah.
And to handle that leap without the whole system just completely breaking down, the course outlines a very rigid three-stage pipeline to structure our approach.
Which is?
Generate, evaluate, and then build and ship.
Okay, let's unpack this, starting with that first stage, generation. Because if we want to build a fully autonomous pipeline, we first have to understand how we are even communicating with these visual models, right? We can't just type a dog in a field into a prompt box anymore. We need a totally different mindset.
We do. And to understand why your prompt needs to change, you really have to look under the hood at the mechanics of modern media generation.
Okay, what's going on under there?
Well, the course highlights this concept they call hybrid power. Modern architectures aren't just doing one single process anymore. They are actually combining two entirely different paradigms to make these hyper-realistic images.
Okay.
First, you have the autoregressive component.
So autoregressive, that's like the traditional transformer models we use for text, right? Where it predicts the next word in a sequence.
Yes, exactly. But applied to visuals. So it is incredibly good at strict instruction following, global semantic structure, and layout composition.
Okay, so it understands where things should physically sit in a frame.
Right. It knows a dog should be on the grass, not floating in the sky.
So the autoregressive part is kind of like the architect. It draws the blueprints and places the bones in the right spot.
That's a great way to look at it. But a blueprint, or a skeleton, isn't a photorealistic image.
Right. Nobody wants to look at just a skeleton.
Exactly. So that autoregressive output is then fed into a diffusion pipeline. And diffusion is a totally different mechanic.
Oh, so?
It starts with pure random noise, literally like TV static.
Yeah.
And it iteratively carves away details step by step to reveal high-fidelity textures, lighting, and rich visual coherence.
Oh, wow. So it's like the interior decorator coming in after the architect, chiseling out the hyper-realistic skin and texture from that static. But if the engine is that sophisticated, throwing a simple prompt, like a dog at it, is drastically underutilizing the tech. It's like, I don't know, buying a Ferrari just to drive to the end of your driveway.
Which is exactly why the curriculum insists you have to adopt what they call the director's mindset.
The director's mindset.
Right. You are no longer a requester throwing a wish into a wishing well. You are a film director on a set.
I like that.
For image generation, this requires a highly structured six-field formula. You have to explicitly define the subject, the action, the location, the composition or camera angle, the lighting, and the style.
Think about how different that is from what you're probably used to doing with AI. It's the difference between handing a chef a vague grocery list saying like, hey, make me some chicken, versus handing them a precise recipe with exact oven temperatures, resting times, and plating instructions.
Yes, the specificity is key.
There's a really great example in the notes that highlights this. Instead of just asking for a picture of a person, the prompt specifically asks for a subject explaining visual proof of the Pythagorean theorem.
Notice what that does. You are giving the AI an active spatial task to render. You aren't just asking for a noun, you are demanding a dynamic interaction within the frame.
And then when you move from images to video generation, that formula gets even more intense, right? Because you have to factor in the time axis.
Exactly. Video isn't static, so the prompt is broken down into 3 specific keyword groups: main attributes, camera components, and audio components.
And that last piece, the audio, is critical, especially when you look at the specific models the curriculum focuses on. The course relies on 2 main tools.
Right.
For rapid image generation, it uses Nano Banana, which is the internal code name for the Gemini 2.3.1 flash image model.
Nano Banana, yeah. Great name.
It is. But for video, it uses Google's Veo. And I really want to pause on Veo for a second because the way it handles audio completely blew my mind.
It is game changer.
Because traditional video generation tools just make a silent movie, and then maybe, you bolt some sound on afterward in post-production.
Right, you sync it up later.
But Veo natively generates and synchronizes the audio directly from the text prompt alongside the visual frame.
It's a completely organic process. Dialogue, background music, the sound of footsteps on gravel, it's all generated simultaneously.
That is wild.
Because the model understands the physical space it's rendering, the audio shares the same latent space as the visuals.
So if it renders a heavy object falling, the temporal timing of the thud audio perfectly matches the visual impact.
Exactly. The physics and the sound are linked.
That is just incredible. But okay, here is the massive roadblock we inevitably hit. Let's say you've mastered this generation piece, you have your director's hat on, you're using Veo, you're making gorgeous assets.
Right.
If our goal is to build an autonomous system that works at a massive scale, like churning out thousands of variations for an ad campaign, a human being cannot physically sit around checking every single frame to make sure the lighting is right.
Right. If you require a human to watch every single video, you haven't actually built an autonomous system.
You've just built a faster assembly line.
Exactly. An assembly line that still gets bottlenecked by a human inspector.
But how do you automate the inspector? This is where I struggled with the notes at first, because art is completely subjective.
It is.
If I write a Python script, it either compiles or it crashes. It's totally objective. But a prompt for a moody cinematic shot of a coffee cup has no mathematical ground truth to compare against.
True.
So how can an AI objectively judge if a generated video scene actually has the right vibe?
That is the core paradox of evaluating generative media. Scaling requires automation, but rigid mathematical filters usually completely miss the qualitative nuance of art.
Right.
So the curriculum introduces a 4-tier hybrid evaluation framework to solve this. It's really designed to balance scale, cost, and qualitative depth.
Okay, walk me through how these tiers actually work.
Sure. So Tier 1 is a tool called SigLIP. Right. That stands for Sigmoid Language Image Pre-training. This is your baseline mathematical metric. It is a dual encoder that independently takes your text prompt and your generated image and projects them both into a shared mathematical space to see how close they are.
Wait, hold on. Projects them into a shared mathematical space. What does that actually look like for someone who isn't a data scientist?
Okay, think of it like an enormous library where instead of sorting books alphabetically, everything is sorted by meaning.
Okay, sorted by meaning.
Right, so a book describing a dog and a photograph of a dog will be placed on the exact same shelf.
Ah, I see.
A dual encoder essentially acts like 2 separate librarians.
Yeah.
One who only reads text and one who only looks at pictures.
Okay.
They take your prompt and your generated image, run into this massive library, and see how far apart those 2 concepts are placed.
Oh, that's a brilliant way to explain it.
Thanks. SigLIP then spits out a deterministic score from 0 to 1. If the score is 0.9, the text and the image are on the same shelf.
Okay, that makes perfect sense. So it's incredibly fast and computationally cheap. It can process thousands of images a minute.
Exactly.
But the downside is that it's completely blind to qualitative reasoning, right? It can tell me that the image matches the prompt dog in a hat, but it can't tell me if the hat looks incredibly ugly or poorly drawn.
Well, I mean, yes, that is the limitation, which is why Tier 1 alone isn't enough. You push the assets that actually pass Tier 1 into Tier 2.
Which is?
The LLM-as-a-judge.
Right.
Here, you take a multimodal model, like Gemini, and you feed it the prompt, the generated image, and a set of natural language criteria. This tier handles all the subjective reasoning.
So this is where we actually ask an AI to critique the art.
Yes,
Right.
it evaluates layout composition, color theory, artistic texture, and most importantly, it doesn't just spit out a sterile number.
Right, because a number doesn't help you fix it.
Exactly. It outputs nuanced, actionable text feedback explaining why it made that judgment. Like, the lighting is too harsh on the left side, or the typography is clashing with the background.
But sometimes a whole paragraph of feedback is too messy for an automated system to parse. If you're building a rigid pipeline, you need something more granular. Which brings us to Tier 3, structured rubrics.
Yes.
The course highlights a tool called Gecko for this, and I absolutely love the metaphor for Gecko. It's basically taking a vague, pretentious art critic and turning them into an incredibly pedantic building inspector with a very long clipboard.
That is a perfect way to describe it. Gecko takes your complex, paragraph-long prompt and automatically decomposes it into discrete, binary questions.
So if your prompt is a black cat sitting to the right of a red flower pot, Gecko breaks that down into a checklist.
A literal pass-fail list.
Right. Is there a cat? Pass or fail. Is the cat black? Pass or fail. Is there a flower pot? Pass or fail. Is it red? Pass or fail. Is the cat to the right of it? Pass or fail.
Right. It pinpoints the exact point of failure. If the image fails, the system knows precisely which element was missing or incorrect, rather than just getting a vague, 70% success score.
Which is infinitely more useful for an automated system.
Exactly. And then finally, we have Tier 4, human evaluation.
The humans still have a job.
We do. But Tier 4 is reserved strictly as the gold standard. You only use human evaluators for final policy gates, big brand identity checks before publication, or preference testing.
Think about how much time you spend in your daily life just reviewing work. This tiered system essentially outsources the entire middle management layer of creativity.
That's exactly what it's doing.
You push the heavy lifting down to the cheap, fast metrics like SigLIP, use the LLMs to catch the qualitative errors, use Gecko for the pedantic checklist, and fix the anomalies before a human ever has to even look at it.
And that leads perfectly into the third stage of the pipeline, build and ship. Because now that we know how to generate the art, and we have the rubrics to grade the art, we have to wire these pieces together into a cohesive brain.
An agent that can actively correct its own mistakes in real time.
Exactly.
So how do we actually wire it up?
The course utilizes Google's Agent Development Kit, or ADK. It's an architecture built on 3 core pillars. First, the model, which acts as the reasoning engine, the brain.
Okay.
Second, the tools, which are the specialized Python functions the agent can use. And third, the instruction, which is the system, prompt laying out the rules of engagement.
I want to dig into the tools part for a second. The notes emphasize that these tools use incredibly rigid JSON schemas so the model can invoke them predictably. Why is that necessary? Why can't the brain just talk to the image generator naturally?
Because large language models are, by nature, chatty.
Chatty.
Yeah, they want to give you conversational fluff. If your automated pipeline needs a specific code command to trigger a server, and the AI responds with, "Sure thing, here's the command you requested," those extra conversational words will instantly crash the server.
Oh, because the server's just expecting pure code.
Right. A JSON schema forces the AI to use a highly structured fill-in-the-blank form. It constrains that chaotic creative energy into a predictable, machine-readable format.
Ah,
Okay.
okay. So it's basically forcing the AI to speak bureaucratic software language instead of conversational English.
Exactly.
Let's look at how this plays out in the real world with the image agent workflow from the notes, because this makes it really concrete.
Walk us through it.
So it runs a 4-tool process. First, it uses a tool to analyze a corporate brand style guide, extracting the hex codes, the typography, the specific shadow properties.
Grounding it in the brand.
Right. Second, it generates high-level design concepts based on a user's brief. Third, it generates the actual UI mockup image using Nano Banana. And fourth, it calls the evaluator tool.
And that evaluator tool doesn't just say, looks good. It judges the image against the 4 CRP design principles.
BRP.
Yeah, contrast, repetition, alignment, and proximity. It scores each one, averages them out, and checks if it passes a strict threshold.
So the agent is essentially playing creative ping pong with itself. It draws something, grades it against those design principles, and if it fails, it takes its own feedback, tweaks the prompt, and draws it again.
Self-correction in action.
But my immediate thought reading this was, what happens if it just keeps failing? Does it get stuck in an infinite loop of terrible drawings just burning through compute credits?
That is a very real risk, which is why the ADK implements a strict fallback mechanism. The system is explicitly instructed to cap prompt retries at exactly one.
Just one retry.
Yes. If it tries to fix the image based on its own critique, generates a second image, and that second image also fails the evaluation, the agent's logic kicks in. It recognizes that the underlying design concept is fundamentally flawed.
It knows when to cut its losses.
Exactly. It completely scraps that concept, loops all the way back to tool number 2, and generates a brand new design concept from scratch.
That is incredible. But the video agent handles the swoop even more elegantly. Let's talk about that corrupted audio simulation we teased at the very beginning of the deep dive. This is the story that really sold me on the power of this architecture.
It's a brilliant stress test. The course instructors intentionally built a multi-agent system to create an explainer video, but they forced the agent to use a script composed of absolute gibberish.
Right, technical buzzwords that meant nothing together, like the quantum blockchain leverages distributed photon matrices.
Pure nonsense.
Okay.
As the agent generates the video, it makes the visual frames, it synthesizes the audio narration of this gibberish script, and then it hits the evaluation stage.
And what happens?
The evaluate tool parses the output and successfully flags a massive failure. It notices that the audio coherence scores under a 3.0 out of 5.
Okay.
But here is the genius of the multi-agent system. Instead of throwing a tantrum and scrapping the entire scene, which would waste a massive amount of computing power, the agent isolates the specific variable that failed.
It realizes, hey, the visuals I generated of a high-tech server room look fantastic. The problem is only the audio.
Precisely. It preserved the visual reference frame it had already generated. It bypassed the visual regeneration step entirely, rewrote the script to be coherent, and autonomously retried just the audio generation step,
Wow.
laying the corrected narration over the original visuals.
It pinpointed the exact point of failure and performed surgical maintenance on itself.
It's mind-blowing.
But hearing all of this JSON schemas, multi-tool pipelines, evaluation loops, fallback mechanisms, if I'm listening to this, I'm thinking, okay, this sounds amazing, but I need a PhD in computer science and 10,000 lines of Python code to build one of these autonomous agencies.
And here's where it gets really interesting. You don't.
You don't.
No. The course introduces a totally new development paradigm called vibe coding.
Vibe coding, that sounds like something a DJ does, not a software engineer.
It really does. But it is a massive shift in how developers actually work with these systems. Instead of handwriting all that heavy, complex 80K Python code, the API calls, the logic loops, the error handling developers use the Gemini CLI.
The command line interface?
Right. You essentially write your agent's overarching goals in plain English inside a simple markdown file. They call these agent skills.
Wait, I want to make sure I understand this. You're saying I don't write the logic loops. I literally just write a plain English goal, like take a blog post URL, extract the key points, and turn it into a branded infographic.
Exactly.
And the CLI does what? Exactly.
The CLI acts as a compiler for your intentions. It reads your plain English markdown file, and it automatically scaffolds the entire ADK workspace for you.
Are you serious?
Yes. It writes the consolidated Python scripts, it connects the tools, it routes the Vertex AI endpoints, it builds the machine based on your description of what the machine should do.
The AI builds the AI agent. That is staggering. I'm just managing the vibes, the overarching logic, and the goals.
Hence, vibe coding.
I do want to point out one technical caveat mentioned in the curriculum for anyone who might actually go build this today. The notes explicitly warn about a quirk when routing these endpoints in Vertex AI for the newer Gemini 3.x models.
Right, the routing is...
Yeah, the target location absolutely must be set to global, or you will trigger an immediate 404 error.
Yes, that's a very important practical detail. And the reason why is architectural. The global routing tables are required to manage the massive distributed compute load of these newer multimodal models.
As they're just so huge.
Exactly. The processing isn't just localized to a single regional data center anymore. It needs to ping the global network to allocate the resources. If you try to constrain it locally, the API just won't find the model.
That makes total sense. So we have this immense automated power. We are vibe coding autonomous agencies that can pull URLs, evaluate their own art, and fix their own mistakes.
It's powerful stuff.
But with that kind of power running on autopilot, there's a glaring need for responsibility. If an agent is running itself, how do we protect the end user? How do we stop this incredibly efficient machine from efficiently generating something harmful or totally off-brand?
The final lesson of the curriculum tackles exactly that, responsible shipping. And it breaks pipeline protection down into 2 distinct layers.
Okay, what's the first layer?
The first layer is built-in protection. These are the guardrails baked directly into the foundational models themselves by the developers. This includes active safety filters that screen prompts before they are ever processed, and DeepMind's Synthed.
Scented, that's the digital watermarking technology, correct?
Yes. It embeds a completely invisible cryptographic marker into the pixels of every single generated image and the audio waves of every video asset.
So it's baked into the file itself.
Exactly. This ensures that no matter where that media ends up, whether it's compressed, cropped, or shared across social media, it can always be mathematically verified and identified as AI-generated.
So that handles the baseline societal safety. It stops deepfakes and harmful content. But what about a company's specific brand guidelines? The built-in safety filter isn't going to block an image of a competitor's logo, but your marketing department definitely wants that blocked.
Right. For that, you need the second layer, application layer protection. This is where you programmatically inject your own custom logic into the pipeline.
How do you do that?
You use system instructions as a structural prefix to enforce global rules, like mandating that all outputs must be in a minimalist style or explicitly restricting off-topic subjects. And crucially, you deploy the LLM as a filter.
So we take that same LLM evaluator we use for quality control in Tier 2, but instead of asking it to judge the lighting, we point it at brand safety.
Precisely. It operates dynamically during the pipeline execution.
Right.
It provides nuanced, context-aware reasoning to enforce brand compliance and cultural sensitivity before the generated asset ever reaches the user.
And if it catches something?
If the agent generates something that violates the brand guidelines, the LLM as a filter catches it and triggers the fallback mechanism to start over.
So what does this all mean for you, the listener? It means the era of being just a prompt engineer is evolving very, very quickly. You are no longer just asking a super fast typist to write a single memo.
Not at all.
You are an orchestrator. You are building systems, autonomous, creative agencies that have the capacity to critique, refine, and perfect their own work before they ever present it to you. You are designing the recipe, hiring the taste testers, and managing the entire restaurant.
And if we look at the course's next generation resources, it gives us a glimpse of where this orchestration is heading next.
Oh.
Throughout this deep dive, we've been talking about generating and evaluating static assets, a video file you watch on a screen. But the course points heavily toward a coming shift toward world models, like Genie 3.
World models.
Models that move beyond producing a flat video file and start simulating entirely interactive, navigable virtual environments in real time.
Right.
Generating the physics, the lighting, the textures of a 3D space as you move through it.
Whoa. So if today we are building autonomous agents that can generate and self-correct a 10-second video clip,
Yep.
tomorrow, what happens when these agents are tasked with generating an interactive reality? How on earth do we build automated 4-tier evaluation loops for an AI-generated world that you can actually step inside?
That is the frontier we are rapidly approaching.
That is a wild, wild thought to leave you with. The old input-output machine is officially broken, and the creative possibilities ahead are massive. Thank you for joining us on this deep dive. We'll see you next time.